Okay, now we are going to explain the formation of an image by using 10 lenses using ray diagram. Alright, so generally we have two kind of lenses. We have a convex lens and concave lens. Here I have two kind of lens. So this is a convex and this is concave. So lens is a simplest optical device. So it has two refracting surface. So here and here, and also for this concave lens, we have in the reflecting surface is into the inner part. Okay, both acts differently. Okay, so now we want to understand what happens if light passing through these two lenses. Alright, so we start with the convex lens. So convex lens of this type, it has two refracting surface. So you can consider this is air and this is glass. Okay, and then I will make it bigger so that we can understand what happens if light passing through the lens, this convex lens. Alright, so generally convex lens is made up of a refracting surface where it has a center of curvature here, and for this surface it has center of curvature here. So that's mean we can imagine that it is a combination of two spherical refracting surface. Alright, so if we have light coming into the lens, directly into the lens, so what happened here is that we have if we draw the normal line, we have incident angle 0 and refracted angle 0. So the light will be not deviated, light passing through the lens, and at this interface, let's consider this is glass and this is air. Alright, so the same thing happened here because when we draw the normal, which is perpendicular to the surface, so the incident angle is 0 and refracted angle is 0. So this light, this light will go undeviated. So what happened to light at different position? Alright, so let's see what happened. Parallel light coming, go to the alright, so we draw one ray here. Okay, so where will be the refracting ray? So to help us, we have to draw a normal line at this point. So to draw the normal line means that we put our pencil here and its center of curvature, so that we have here is the normal line. Okay, so that is our normal line. So when the light coming to higher index, it will be closer to the normal. So we can expect that the light will go in this way. Alright, so you see the light start to bend, and then at this interface we draw another normal line. Okay, alright, and then when the light go to the lower refractive index, it will go farther from the normal line. So we expect the light should be deviated in this way. Okay, so you see for this light, when it hits the surface, it will start to bend toward this point. Okay, how about another point? So we can draw to another ray which is parallel. So I can see maybe here a little bit farther from the middle center. Okay, so for here, so light enter, and then we can draw the normal line. Okay, So the light will, sorry, the light will go um, okay, so the light will be closer to the normal, so we can expect it to be around here. And then we draw normal line to this surface. This is normal line. Okay, so it will go away here. Okay, so we see that these three rays bend and then focus to one point. Okay, so if we draw properly for all rays which hit parallel to the what we call this is optic axis. If we draw rays which are parallel to each other, all of them will be focused at one point. We call it as a focal point. And the distance from the lens here is f. We call it as focal length. Alright. So this is what happens if light passing through the convex lens and will get focus. And this distance depends on how thick is the lens. If the lens is thin, this will be focused farther. So you can verify that. So if it's so thick, the focus will go further. So we can say that the focal length of the lens is inversely proportional to the thickness of the lens. All right. In a simplified version of a ray diagram, okay. So this is what we have done previously. So we have light passing through. Okay, and this refract and focus. This is just a sketch. Focus. Okay, so in a ray diagram, we simplify this phenomena into just an arrow which represents the convex lens, and then we have optic axis, and then we have rays 1, 2, and also 3, which is undeviated. This represents this light ray, and we have the light passing through the optic axis. Okay, so this is the simplified version of convex lens.